Let's take a look at number 60 now, which is asking us to take the derivative of secant of the square root of t squared minus 9. I'm fine with the secant the way that it's written right here. Let me do that in blue. But one thing I'm still recommending for you guys as we're kind of getting our feet wet here, not to try to differentiate through a square root sign. So what I'd probably do is rewrite this now as the secant of, and then I think I'd start a set of brackets. And within those brackets, I think I'm going to take the binomial quantity t squared minus 9, and instead of a square root, I think I'm going to take that to the 1/2 power. So that, I think, is the best way to rewrite this original function. And now as we go to take the derivative of y with respect to t, let's ask ourselves, what is the outermost thing happening here? I think that's the secant. So we've got secant of some angle here. Let's get working then. The derivative of secant of an angle, try to say it right, guys. The derivative of secant of an angle is secant of the same angle times the tangent of the same angle. So it's a little bit cumbersome, but this is going to be secant of, and again, t squared minus 9 to the 1/2. So it's secant of the same angle times tangent of the exact same angle again, t squared minus 9 to the 1/2 power. So let's get that right. Derivative of secant of an angle is secant of the same angle times tangent of the same angle times the derivative of the angle itself. So what I've got right here in red, we're now going to need to multiply here by the derivative of that. So what's going on there inside those brackets? We've got a binomial quantity to the 1/2 power. So I'm going to use the power rule here. That's going to be a 1/2 times the same base, t squared minus 9, now to the negative 1/2 power. But wait, there's more, times the derivative within. So the derivative of the base right there is going to get multiplied here. And the derivative of t squared minus 9 is going to give us a 2t right there. And that's as far as we need to go with that one. So the calculus is done. Now it's a question of just cleaning this answer up a little bit. And boy, I've got a secant, I've got a tangent, I've got a 1/2 and a 2. One thing I noticed right away is that the 1/2 would multiply by the 2, and those are just going to cancel each other out. Because I've got this right here, t squared minus 9 to the negative 1/2 power, that negative power tells me that I'm going to have a fraction. In fact, I'm going to go ahead and deal with that right now. A negative 1/2 power is a square root in the denominator of t squared minus 9. So that takes care of that. And now what's left in my numerator is going to be the secant of the original angle. And I'll go back to the original format that they used here. T squared minus 9 to the 1/2 power is going to be the square root of t squared minus 9. So it's secant of that angle multiplied by the tangent of the exact same angle again, t squared minus 9. So that goes there. And that, you guys, I think is all we can do with problem number 60. Good for you if you thought about this, but secant multiplied by tangent, I don't believe that does anything. Secant is 1 over cosine. Tangent is sine over cosine. Yeah, and nothing cancels out there, guys. So I guess you could make this sine of that angle divided by cosine squared of that angle, but that doesn't seem any better off than where we left it here just a minute ago. So that is going to be our final answer here for problem number 60. Wait, JK, I'm back. I forgot about that little t right over there that I didn't cancel out. So that, of course, would need to be a factor in the numerator as well. Sorry about that, guys. So it's t times the secant of the square root of t squared minus 9 times the tangent of the square root of t squared minus 9 all over square root of t squared minus 9. Whew! Now, there we go. Now we're done with number 60.